Good afternoon, President Wei-Kuo, Sir David Jones, Professor Jorge Cashmore, colleagues, friends, and fellow students. Good afternoon. I'm Jian Lu, Vice President of Research and Technology of City University of Hong Kong, and the facilitator for today's lecture. Welcome all of you to the City University Distinguished Lecture Series. Today, we are honored to have Professor Roger Cashmore to deliver a CTU Distinguished Lecture. Professor Cashmore is the chairman of the United Kingdom Atomic Energy Authority. He's a fellow of Royal Society, and in 2010, he led the Royal Society Working Group on Nuclear Proliferation. Professor Cashmore's research interests include the origin of the masses of particles of the Higgs boson. He is a former principal of Brasenose College in Oxford and is a professor of experimental physics at the University of Oxford. Before returning to Oxford, he was Director of Research and Deputy Director General of CERN, the European High Energy Physics Laboratory in Geneva, where he was responsible for the experimental program as a Large Hadron Collider. Before leaving CERN, he was chairman of physics in Oxford. During his teaching and research career, he has more than 200 publications in learning journals, and Professor Cashmore was awarded the C.V. Boyce Prize of the Institute of Physics and a Research Award by Alexander von Humboldt Foundation in Germany. In 2004, he made a Companion of the Order of Saint Michel and St. George for services to international particle physics. Today, Professor Cashmore will deliver a lecture titled Sustainable Energy and Sustainable Environment for the 21st Century, the Role of Nuclear Power Generation. So may I now invite Professor Cashmore to deliver the lecture to us. Thank you very much. Cashmore, please.
Right, good afternoon, ladies and gentlemen. I must say it's a great pleasure to be here to give this lecture. And today I want to take you through what I think are some very important issues that we've all got to face throughout the world concerning the energy that we're going to need for everybody in the world and how we make that consistent with a sustainable a sustainable environment for the whole of the world throughout the 21st century. So I'm going to cover a lot of ground. Some of it will be very superficial, and perhaps all of it will be very superficial, but there will be questions time at the end, so you can take me up on anything that I say that you want to follow up on. Now, I'm going to try and couch this largely scientific lecture in terms of what the needs of our global community are going to be in the future. And the issues that I'm going to be addressing, first of all, are going to be those of world population, because as we see, that's an inevitable driver for the amount of energy that you need. We're going to talk a bit more about that energy demand and how it's dealt with, and how we use that energy, because that's going to become an important factor in how we go forward in the 21st century. And inevitably, and very importantly, I'm going to be talking about emissions, particularly those of carbon dioxide, and the effects on the climate. And the importance of that being that as far as the climate is concerned, as far as emissions are concerned, then what anybody does in the world, in any particular place of it, affects the rest of the world. So it really is a global issue that we are all, wherever we are in the world, are going to have to deal with. So let's look first of all at the first driver, and that's the world population. And the world population, you can see here, is a projection of what is going to happen to it. Here we are, roughly speaking, at somewhere around 6 or 7 billion. And here's the projection for what will happen up to 2050. In fact, you can find projections which will take this higher in that time period. So we're going to have a much bigger population on the globe. And of course, that bigger population is going to need energy to be sustained, to have food, to drink, to have warmth, to have all of the things that you and I are actually used to. So that's the first thing. It's an inevitability unless that rate of increase changes, and there's no sign of it changing. Now, what does that do for energy consumption? And what I want to show you here is the projections, and these projections, they vary when they're made, but they all have the same story to tell. You see here that in 1990 we're using 354 quadrillion BTUs. The units change, but they're all related to one another. The main point here, though, is to see that since that time, we're now at 2015, we've already increased since 1990 by a substantial amount. It's probably around here at the moment, perhaps not quite as high as that. But the projection, because of that growth, and also the fact that wealth, or we hope wealth, will be being acquired by underdeveloped, less developed parts of the world, will need not only a demand due to the increased population, but also due to that increased population wanting a higher standard of living, which usually means more energy. And here you can see up to 2035 the projection of where that will go. So it is going to increase by another 40% from where we are now. And you can see another thing that's rather important, that increase is mainly in all of the developing parts of the world, the non-OECD countries. So one part of the world is roughly constant, with roughly a constant population, whereas the other parts of the world are going to grow dramatically in that time, as we've seen on the previous plot, and increase the amount of energy that's needed to keep them in a reasonable state. Now you have to ask yourself where that energy comes from. And here you see a pie of the sources of the energy in 2007 and the projected sources in 2030. And I want to point out to you here that this is a very frightening plot, because here you can see that in 2007 we were taking about 80% of that energy was provided by oil, coal or gas, fossil fuels. And they clearly, when you burn them, give CO2, and I'm going to be coming back to the impacts of CO2 emissions on the climate. But the frightening thing is that when you get to 2030, then the ratio of fossil fuel as the source of the primary energy is basically unchanged. It's still 80%. Remember, in that time, there's been a roughly a 40% increase in the amount of energy that's being consumed, 500 up to 700 in another set of units. But it hasn't changed. So what we're doing today is what we would be expecting to be doing in 2030. And that actually is something that the world is beginning to realize just is not possible. And we're going to discuss that in some depth. So that brings me on to the comments now of emissions, CO2, and the climate. And I want to go through this fairly gently to make the point, and I hope I leave you in no doubt, that there is a big effect of climate warming. There really is climate change. And we'll see both the effects of that and also the measurements that tell you that's happening. And here I want to show you the CO2 content of the atmosphere, in this case parts per million of the atmosphere. And you can see over 400,000 years, this has its ups and its downs, but it's really been constant around 250 to 300 parts per million. But from this point on, it seems to take off. And the concern of all people who are worrying about climate is that this goes up, and this is more and more CO2, more and more greenhouse gas in the atmosphere, which leads to a warming of the globe. That is the worry, and this is obviously a very tight scale. So let's see what happens here when we look in a bit more detail at recent times. And here we see 1750, and here we see roughly where we are today. And you can see that there's a clear increase, and that increase has been accelerating over this period of time, corresponding to the world becoming more and more industrialized. And I have to say that, of course, coming from Britain, from the UK, we were very largely responsible for the development of the industrial world, the industrial society, the industrial revolution. You also see that beyond carbon dioxide, methane increases. This is a slightly different scale. This is parts per billion. But you have to remember that methane is even worse of a greenhouse gas than carbon dioxide. Even this small amount is quite a dramatic contribution. And then nitrous oxide as well down here, all of them increasing over this period of time when there has been a large increase in the population and an industrialization of an urbanization of the population. So the greenhouse gases, there's no doubt that their content is going up. And here again, you see on another presentation of it, here this in terms of billions, gigatons of carbon dioxide equivalent that's emitted into the atmosphere. And here we are in about 2000, and we're in this region here somewhere around the 30 to 40 billion tons, 40,000 million tons of carbon dioxide is emitted up into the atmosphere every year. What I like to say is the atmosphere up above you, it sometimes will look blue on a good day, but you have to remember, it is the biggest waste dumping ground on the globe. That's where we put 30 billion tons of waste every year. And it will have its effects. You would expect that to be the case. Now, those are things. What are the manifestations of those effects? And I just want to, you can look at lots of indicators, but I want you to just look perhaps at one that we'll all agree, I think you have to respect. And this is here, look at sea level. This is 1950, this is 1900. The sea level around the globe has gone up by between 15 and 20 centimeters. The sea is that much higher. Right? And that's a physical measurement. You can put rulers or whatever you want into the water off Hong Kong and measure it on an average over the year. You will have found out that this is the increase that the sea level, rise in the sea level. And of course you know that that has nasty consequences if you live in low-lying islands in the Indian Ocean, for instance, or low-lying land near the sea, for instance, in Bangladesh, where a lot of land and habitable land will be lost if this continues over and above what has already been lost. So when you just look and there are other indicators there. They all show the same thing to bigger and lesser extents. But that, I think, is, for me, is one of the most obvious ones, that it's hard for anybody not to think that you can get the measure of the height of the sea level wrong. Here's another one, which is the average temperature of the surface of the Earth in 1955, 65, and 75, 50 years ago, roughly speaking. And what I'm going to show you in a moment is what happens in the years from 2006 to 2011. And remember, where you see red, it's hotter. So here's there they are, and anything that's not blue means, say, it's got hotter. And it's clear that there are enormous increases in temperature over the average of these years here. We really have got a surface of the Earth that is getting hotter. And that's going to have lots of consequences.